Question 1 asks us to calculate the concentration of ions in the following saturated solutions. To start off, we'll go ahead and write out the dissociation equilibrium. For A, we're given that we have 9.1 times 10 to the negative 9 molarity of Ag+. And as we can see, for every 1 mole of silver cation, we have 1 mole of iodine ion. So question A is pretty intuitive in that our concentration of iodine ions is equal to 9.1 times 10 to the negative 9. And that's because from the dissociation, we can see that for every 1 mole of silver, we have 1 mole of iodine ion. For question B, we're asked to calculate the concentration of aluminum cations in aluminum hydroxide solution with hydroxide ions equal the molarity of hydroxide ions equal to 2.9 times 10 to the negative 9 molarity. To start, we'll write out the dissociation. The KSP is equal to the product of aluminum cations and hydroxide ions raised to the power of 3, because for every 1 aluminum cation, we have 3 hydroxide ions. The question asks us for the concentration of aluminum cations, so we'll switch this equation around and by getting this by itself on the left-hand side. Now that we have our equation, we need to determine the value of KSP. And since that isn't given to us, you can either look it up in your chemistry textbook by your teacher, or you can do a quick Google search. And that value is going to be equal to 1.8 times 10 to the negative 33. And then our concentration of hydroxide ions is given to us up here. Now we can go ahead and plug these into our equation, and we get 1.8 times 10 to the negative 33 over 2.9 times 10 to the power of negative 9, and be careful to remember that it is raised to the power of 3. And make sure when you're dividing this out that you do the exponents last, so we'll have 1.8 times 10 divided by 2.9 times 10, which will give us 0.75, and then our exponents will be negative 33 minus negative 9, which equals negative 24, and then divided by 3 equals 8. So our final answer will be 7.5 times 10 to the negative 8.